morning, ma'am. Good morning, friends. Uh, I am a student in ACTS October batch 2023. Today I am representing the presentation topic is reporting and documenting a specific small building New Zealand construction industry. So we will discussing the topics about importance and relevance of small building design in the New Zealand, discussion on functionality, sustainability, user needs, materials, times and cost implications impact the design processes, determine design criteria and safety factors in assessing design loads, explore factors influencing design criteria selection, analyze of the key structural elements, foundation and substructure requirements, and last one is conclusion. The first topic is importance and relevance of small building design in the New Zealand. So designs that are small and efficient, save energy, emit less carbon dioxide and have little effect on the environment. Small buildings designs are in line with the New Zealand's goals for a greener future. Because of the country's commitment to sustainability and vulnerability to climate change, little structures regularly require less materials during development and less continuous support. Moderating assets like wood, steel and water. This is particularly applicable in New Zealand, where some structural materials should be imported, making assessed preservation urgent for maintainability and versatility. Because of their lower construction costs, small buildings are more affordable for a wider range of individuals, including first-time home buyers, young families, and those with lower incomes. In a nation where loading responsibleness is a critical issue, a little structure configuration can assist with tendering to this test by giving more reasonable loading choice. The next topic is discussion on functionality, sustainability, user needs, materials, times and cost implications impact the design processes. The first one is functionality. The goal of functionality design is to make sure that the finished product serves its intended purposes well and quickly. This includes understanding client necessities and planning arrangements that satisfy those requirements. And decisions regarding the design's layout, features and usability, they are influenced by functional considerations. The next is sustainability. Sustainability plays a significant role in design decisions. Designers need to think about how their choices will affect the environment, such as how much energy they use, how much waste they produce, and the materials they use. Economical plan standards focus on inhospitable assets, energy of proficiency, squander, decrease and recyclability. This might include choosing accommodating materials, integrating energy saving innovations and planning for lifespan and flexibility. And next is user needs. Figuring out the requirements, inclinations and ways of behaving of the end clients is central to the plan cycle. In order to gain insight into user demographics, preferences and pain points, designers must conduct extensive research. Designers can create products that are user friendly, intuitive and tailored to the needs of the target audience by incorporating user feedback and usability testing into the design process. Next is materials. The choice of material has a significant impact on sustainability and functionality. Planners should consider factors like strength, style, accessibility, cost, and ecological effect while picking materials for development to reduce one's carbon footprint and encourage resource conservation. Environmentally friendly materials such as recycled or reclaimed materials, low impact alternatives, and locally sourced materials are frequently favored. And next is time. Time requirement assume a significant part in the plant cycle, especially in high speed enterprises or tasks with tight cut-off times. Planners should adjust the requirements for careful exploration, ideation, prototyping, and testing with the task force of events. Compelling time uses techniques, for example, focusing on undertakings, setting sensible cut-off times, and utilizing effective plan approaches and philosophies are fundamental for granting ideal task fulfillment without compromising quality. The next one is cost implications. Because they have a direct impact on project viability and budgetary constraints. Cost considerations are essential part of the design process. Organizers should cautiously assess the expense ramifications of plan choices, including material determination, producing processes, work expenses, and above costs of setting plan aim with monetary limitations require vital preparation. Easton designing and money saving advantage investigation to streamline assessed portion and boost project Easton. And the next topic is determine design criteria and safety factors in assessing design loads. The first one, design criteria. There are some points of design criteria: building regulation and standards. Second is functional requirements, and third is environmental conditions, and fourth service life expectancy, and fifth is aesthetics and ergonomics. The first one is building regulation and standards. Design loads must comply to any building regulations and standards unique to the project area. These rules provide the minimal criteria for structural design in order to ensure safety and performance. The second is functional requirements. The structural intended uses determines the design criteria. For example, a residential structure will have different loads needs than a commercial or industrial complex. The third is environmental conditions. Environmental conditions like design loads should take into consideration environmental conditions like wind, snow, seismic activity, and changes in temperature depending on the project's physical location and climate. And fourth is service life expectancy. Create building with an estimated service life in mind, taking into consideration issues like maintenance, damage, and extinctions. And fifth is aesthetics and ergonomics. Consider aesthetic and ergonomic factors that improve user comfort, accessibilities, and visual attractiveness. And second is safety factors. There are some points of safety factors like factors of safety, load, material strength, load factors, redundancy, and resilience. The first one is factor of safety. Safety factors are used to design loads in order to account for uncertainties, variability in material qualities, construction tolerances, and unexpected loads. The factor of safety assures that the structure can take loads greater than the project limit without failing. Load. Second, different types of loads like dead loads, living loads, and environmental loads are coupled using load combinations specified in building regulations. These combinations take into account the simultaneously occurrence of many loads when determining the most important load circumstances. And third is material strength. So, safety factors are also used to guarantee that the actual strength of material exceeds the specified strength under design loads. This explains variances in material quality and production procedures. And fourth is load factors. Use load factors to classify different types of load depending on their properties and consistencies. Because of their instability and unpredictability, wind loads might have different loads factors than dead loads. And fifth is redundancy and resilience. Design system with redundancy and resilience to reduce the impact of unexpected failures or extreme loads situations. This might include implementing backup systems, different load pathways, or fail-safe procedures. And next topic is explore factors influencing design criteria selection. The first one is functional requirements. The principal purpose of the building or product dictates the design standards. A bridge, for example, has different design requirements than a house or a car. And second is regulatory standards and building codes. Respect to regulatory standards and building codes is critical to ensure the safety, performance, and compliance of the design. Design standards must be within the requirements put out by the correct authorities. And third is environmental conditions. The geographical location and environmental factors such as wind, snow, seismic activity, temperature variations, and soil conditions influencing design criteria. Structure in coastal areas may require criteria to withstand hurricanes or tsunamis, while those in seismic zones need to account for earthquake loads. And fourth is economical consideration. Budget constraints and financial matters impact design standards choice. Balancing performance needs with cost effectiveness is critical to obtaining the best design solution. The next step is analyze of key structural elements, foundation and substructure requirements. The first one is key structural elements, columns and beams. These are the major load bearing components that carry loads from the structure to the base. They must be able to bear compressive, tensile and bending forces. Second is walls. According to the construction, walls may be load bearing or partition. They provide stability from the side and may withstand wind and earthquake challenges. And third is foundation. Foundation. Despite actually part of the framework, foundation play an important structural role by spreading the building's load to the ground. Second is foundation. Soil analysis. Evaluating the properties of soil is critical for choosing the kind and quality of foundation necessary. The design of a foundation can be affected by soil carrying capacity, settling characteristics and soil type. And second is load and settlements. Foundation must be constructed to support the structure loads with minimizing excessive settlement that can result in structural damage or stability. Water table. The depth of the water table concerns foundation design, particularly in subject to flooding location or with high groundwater levels. And next is substructure requirements. Footing. Load are distributed from columns and walls to the earth using spread or continuous footings. They must be properly sized and strength. Second is pile caps and grade beams. These elements are used in deep foundation systems to transmit loads from the columns to the building, yet also providing extra support and stability. And third is excavations earthwork. Proper minimizing procedures and soil compaction are required to prepare the site and ensure the integrity of the foundation. Fourth is waterproofing, and drainage. It is vital to protect the structure from flooding in order and prevent moisture related problems like crossings, mold development, and foundation instability. And last is conclusion. In conclusion, reporting and documenting a specific small building in New Zealand construction business are key activities that contribute to project success, safety, and compliance. By carefully recording critical components of the building process like design specifications, material selections, construction procedures, and regulatory compliance, and stakeholders guarantee that the project satisfied industry standards and regulatory requirements. In New Zealand, with strict building rules and seismic concerns are crucial, detailed documentation is critical to granting structural integrity, longevity, and resistance against natural calamities. Thank you.
Thank you so much, Parwinder. Any questions from students? Okay, Parwinder, could you explain the live load and dead load of the buildings and some examples of them?
Dead loads like refers to the structure, to the weight, like floors, walls, roofing, live load to the unload to the moving other side, any like windows, carpet,
Okay, move on.
doors, windows, like
Doors and windows mostly will be dead. Sometimes windows dead low.
Yes.
Because it's not temporary.
yeah.
Okay, thank you so much.
Thank you,
so
ma'am.
much. Thank you.